Well, hi, and thanks for joining me here in my shop. Today I'm going to be going another step or two, or if I can do it, even finishing the calibration process on this tube tester. So the next step involves, according to the service manual or the calibration manual, using a 6L6 tube, and I have a little bit of a bigger view of this tube because I want to be testing more tube testers, and I want to use a tube I can use as the consistent tube between all of them. And it wouldn't just be one tube, it would be a handful of the same tube that I can progressively test through all these testers ultimately. So this is my collection of output tubes that I have. And I did take an inventory. And so the deal is, when it comes to 6L6, I don't have any. Isn't that something? Eh? That's a very, very common tube. I've got none. But let's see. I've got 12L6, 35L6, 50L6, 25L6, 6V, 6W, 6K, 12W6. For some reason, I got a 6SN7 in here for some reason. So you can see my dash marks here of how many I've got. So a good alternative for the 6L6 would simply be picking another L6 with a different filament voltage. I think it's the same tube otherwise. So that would be the safest way to go. That would be a 50L6, of which I have 5 in here. So I have to dig through and find them because I don't have them bagged up. These are probably all the 6W6s here. I got so many 6W6s. Nobody wants them. 50L6 everybody needs. I don't have any. I think that kind of makes sense, doesn't it? So that's the tubes. Now I think we should spend a little bit of time going over the instructions very carefully because there are some misleading steps, and I know at least one of you has been misled based on an email I got. So let's see if we can straighten this out. Okay, so we just finished this step here, checking for the 60 volts based on having a 6C4 tube in the machine. There it is there. We'll remove it. I hope I removed it. Son of a gun. Okay, and that's an example of where this manual comes up just a little bit slack. So here it says, adjust the front panel controls for 6L6 tube as shown in diagram B. Remove the leads from the previous step. So just a comment here. This should really follow logical order. This should be the first statement. Remove the leads from the previous step. The next statement should be, adjust the front panel controls for a 6L6 tube as shown in the diagram. Now, it doesn't say plug the tube in. And you might think, well, why would it? Well, because if you read lower down here, it's going to take me a moment to find this, where this is. Right there. Insert 6L6. So down here it says plug the tube in. As far as I know, nowhere above does it say plug the tube in. It must say pull the tube out at some point in here then. Somewhere. We're going to get down here eventually. The point I'm trying to make, and I'm making it very poorly, is that although they left that statement off, you should plug the tube in. And the reason for this is you can't do these next steps. You know, look for shorts. Well, you can't do it without the tube plugged in. Repeat these steps. You can't do it without the tube plugged in. So you have to have the tube plugged in. It only makes sense. Return test switch to off. Meter switch to off. To test, rather. Without changing any settings, turn instrument off. Boy, I tell you, like, if you just casually read this quickly, these little things can get missed. And you can get to the point where you're doing stuff with the thing still on. Yikes. So you can't read this careful enough. So let's read it. Let's read it careful enough now. Adjust the front panels for a 6L6. So I'm going to do it for a 50L6. I'm sure the only difference is going to be the voltage. Repeat sections 15A, 2 and 3. So let's just basically do the tube test process. Test switch to off. Meter switch to test. Without changing this, turn it off. Then we move a wire. So I haven't even done anything here. All I've done here is basically set it up to test this tube. And when you get it all set up, move this wire, turn it back on, rotate test meter deflects from 0. So we're back to this reflects from 0 thing. And if you can't manage to zero it, reverse some wires. It's the same procedure. So again, I think we're trying to balance for imbalances that are inherent in the transformers. Yeah, there's center tapped, and the center tap not necessarily dead center, that kind of thing. I guess precision is really required in this machine. Replace. Here's another one that I had to read this a few times. Replace lead move to lug 13 of PT4. So that makes perfect sense. I just wouldn't write it like that. Replace lead moved to lug 13. I think I would say remove temporary connection to lug 13 and reconnect to original position of lug 14. I think that's what I would put there. And the rest of this is all that thing where you are making other scales match one scale on the meter. You've now completed the GM. So we're right at the end here. At what point are you actually adjusting the GM reading? And I don't see it here. So, and the GM reading, the GM is a ratio of two values. So how this thing gets GM onto the meter is a mystery to me too. I'm really curious about how it manages to do that. And maybe all these testers do it in different ways. So, okay. Let's set it up now for the 50L6. That's no. Yeah. Adjust. Here we are. Calm down, Jim. Adjust front panel controls for a 6L6 tube as shown in the diagram. If some really bad weather is coming, that's why I'm all excited. Here, look. This is the current radar. Okay, I live right there. This storm just passed over. This one's marching towards us. It's a big, heavy rainstorm. But later today, the temperature is going to plummet, and we're going to get a big snowfall apparently, which I don't know too much about yet. But it's got me all excited. Throwing off. Great. 50L6. Let's do it. 50L6. I'll just set these over here. If these are 50L6s, I don't know anything about them, of course. I don't know what condition they're in exactly. 50L6, we'll get it on here first. 50. Yikes. So what's happening here with the paper roll, if you think about this, there's two dowels with the paper rolled on it. When the dowel is empty of paper, of course, its diameter is small, and when the dowel is wide with paper, the diameter is big. So as you rotate this, since the gears drive both of these to turn at the same amount, if you think about it, when you get to the point where the paper is halfway, there'll be a whole bunch of slack between these wheels, and that's what's going on here. All this slack is showing up, which will tighten up as I get towards the other extreme. Okay, I went right past 50 without thinking. 50L6, there it is, 50L6. Okay, 50. BGAG. BGAG. And it has 6. Put this on 6. Something new here. I haven't put in the EM shunt. Maybe that's for the EM measurement. Am I reading this right? Wait a minute. Oh, there's 2 tests for this tube. 2 tests. Oh, Jim, one is the EM test. Okay, I got my act together. So it's listing 2 tests here. Hard to read the numbers. Wow, you can really make mistakes so easily here. At least I could. So let's start over because I already made a mistake. BJAJ. BGAG, not J. Boy, oh boy, what's going on? I gotta drink more coffee. This is not important because I'm looking at, aha, that's the hint. If it's telling me to adjust this, I'm preparing for the EM test. Otherwise, this is just left, I guess, wherever it is. doesn't matter. 0610. 06. Is that a 4 or a 1? A little bit damaged there. I think it's a 4. 06431. That's what I'm going to go with. 06431. And then the bottom row is 05200. 05200. So we'll be setting the bias to 1.4 volts. Shorts on 2 and 7. So we got to do the bias adjustment, line adjustment. I got to find a tube now. Excuse me. Let me get out. Let me find my 5 tubes. Okay, I've got my 5 50L6 tubes all numbered up. Number 1. Start with number 1. So as far as I know, for all I know, all 5 of these tubes are bad. I have no real idea on here. So this is set for a 50L6. Just double check. BGAG. BGAG. This is the EMGM switch here. I say just kind of realizing that this is not material. 06431. 06431. 0520. 0520. Good. We're heading for 1.4 volts of bias when we get around to it. I think I can turn this on. I think I'm trying to decide whether I should turn it on with the tube in or not. I'm going to switch this to on. Hit it with a little bit of power here. I wonder if you can set the bias without a tube in place. Maybe you can set it roughly. Oh yeah. Oh wow, it's super sensitive, so I don't think you can do it. No, you need something in there. Okay, we'll set the line adjustment here, just ever so slightly higher. And the line voltage today is 122.6, same as always. We'll see how much it dips when I plug this in. In goes the 50. Oh, don't put your fingers under there. Man alive. I tell you, there's lots of attractive ways to get a shock here. It's heating up. See the line voltage. Oh, what was that? Was that me? By the way, my decisions about the meter movement and its stickiness up here is to just carry on and try to do all the work on the lower part of the meter. Maybe the problem will go away. I doubt it. Maybe the problem can be fixed. I doubt that too. So we're just going to live with it. Just as long as the meter gets up into this range, I think I can get along with it. Okay, we'll fix the line adjust problem here. There we go. Now we'll set the bias. Whoa. Oh, it's still just as wild. What happened there? What's caused this super... What's going on? How come it's so sensitive suddenly? This was a real nice control that worked before. Oh my gosh, I gotta be able to set it to 1.4. Is it this switch? Son of a gun. What's going on here? A bit of dirt in this control, maybe. I think I can set it now, can I? Like 1.4 is... Where? Where's 1.4? 1.4 is way down here where my finger is, just where I thought it was. Down here. Oh, I'm just... what a dummy. I just turned the line voltage control. Well, I'm busy making all the mistakes. Gotta get that out of the way, Okay, here we are in bias again. How can I get it to 1? Look at it. It's just gonna fly back and forth. This is crazy. I'm already I'm stumped. Try this meter normal reverse switch. I'm hoping something's not working right here. What is that? Now, you just wouldn't think I'm still in trouble here. You wouldn't think. Oh, almost got it. Wow. It's going to be really, it just won't go in the 1.4 spot. What are you supposed to do now? Now what do you do? Oh, almost got it there. But you know, if I get it there, it's not going to stay there because it's like writing on some dirt. Dirt. Come on, dirt, go away, dirt. This is a great big potentiometer. Oh, it's gotten worse. Ah, I almost had it there. It's not going to happen. I say if I get it there, it's not going to stay there. It's like it got some anti 1.4 juice in it or something. It's just... Stop. See it wandering around now? Oh, maybe you can't really see that. But I imagine I've got this sitting in a dirty spot where it's going to be unreliable. So what are you supposed to do with that? What are you supposed to do with that? How come this control got so super sensitive? It's still doing what it's supposed to do. It's just doing it in a very poor way. Yeah, see, this has just wandered right off. How am I going to do this? Put the bias somewhere where it can be relied on. Well, let's put it at 3. We'll double the bias. For some reason, doubling it sounds like a good idea. I don't know. Oh my gosh. Well, we'll take the tests. I can wiggle this bias and we can watch what happens on the meter. Maybe the bias isn't actually that critical. Fat chance on that, eh? Short test. I should be doing this right off the bat, too. Short test. I'm watching the short light. 2, what was it, 2 and 7? 2, 7. Good show. Test. Test. We're ready for a test, I think. Okay, so what is it supposed to be? On a 50L6, according to this guy, the reject point, 5650. So the scale we're on now, we're on the 20 scale up here. So 56 is in this area here. There we go. It's a good one. That's 5 on the meter. It's supposed to be 56 at the bottom. Not a good one. That means this one's right at the good limit. Now let's fool with the bias because I'm pretty sure we're going to find this makes a big difference here. Oh yeah, look at that. Hey, it doesn't make a difference above a certain amount. So I'd be driving the tube into cutoff. There's a GM suddenly jumped up. So not a lot of difference there. It's like no bias and bias. And what is actually happening to the bias voltage during that little deal? So it's kind of going between 0 and 2.5 is what I'm doing. Well, in this tube, as long as I have it above a certain point, it gets a very steady reading. So I'm going to reach that point there. Let me go a little higher. What is it actually? Well, the bias is around 3. So let's leave it at that. Let's leave it at 3. And we're going to go tube by tube here. So this is tube 1. I better make a note. Tube 1. The GM reading was, we're on it right now. With the bias at 3, the GM is reading exactly 5,000. Bias 3. Okay. Next tube. These get pretty warm. That's number 1. We'll do number 2 next. Okay. Okay, we'll go back to checking the line voltage again. I should have. Well, that would have been very, very close. It was in and off at all. Okay, that's great. We'll check the bias voltage. It's above 3 this time. Why higher? It's that same effect, so it's not the tube that's doing this, of course. So from the last tube's behavior, as long as we have it up a certain distance, we're going to get a fairly consistent reading. Believe that? Shorts. 2 and 7 on the light. 2. 7. Okay, ready for the test. Oh my gosh, this has been on test the whole time. Well, it didn't blow anything up. That's why the bias was reading a little high, because now we're seeing the bias voltage. 3. Get it? Wow. Got to pay attention to what you're doing when you're doing this. That's really a problem for me. We're in test mode. Test that baby. So this one comes out much, much lower. 3,500. 3,500. This is number 2. 3,500. Bias not. Only when you drop it down. So as long as you get above a certain limit, hopefully this isn't negating the. What I'm really trying to do, anyways, eliminate the totally bad tubes out of this process. Okay, leaving it on. I'm pulling it out. Is that a smart move? Leave it on, pull it out. Or put it in, really. Put in a tube into an operating tube tester. Some of them say turn it off, turn it on, but I'm just going to stick it right in there. So if this tube has a dead short in it, this fuse light will go. And I'd be smart during this to put on my own dim lights too. Let's do that. Dim lights in. One of the things I haven't tried is measuring the filament current. Okay, so I saw my dim lights come on, I saw this thing flicker. So we know it's taking current. So I want to check for shorts first. Here we go again. It's 2, 7, and nobody else. Good. Check the line. The line is good. Bias, it's up in the 3. I got this stuck on hold again, so that's how that happens. It doesn't do anything. How does that happen? Check the bias, check the line, check it all again. Bias, line, everything's good, good. Okay, making mistakes left and right, but it's still good. Here we go. What do you got to tell me? 2,500, 3,000. That's 3,000. That one is 3,000. So the GM is a ratio of the variation in the plate current against the variation in plate voltage, and the current is done in milliamps, and the voltage is done in volts. And that gives you a large number in the thousands, like 3,500. Okay, so that guy's done. What I'm having trouble with is taking that number, the GM number, and just realizing something from it clearly. And I should be able to. It's just a ratio. I mean, obviously you can just compare the GMs and go, well, higher GM better too, and you can do that, but I want to go a little further than that. Okay, we'll go back to checking the line, checking the bias. Bias looks a little high now. Just keep it around the same, right around 3 anyway. Test. Test. Okay, man, what do you got? This guy's got 5,400. That's our best one so far. 5,400 on tube number 4. Quickly check the line with the tube operating. Yeah, it's good. Leave it like that. Turn that off there. Pull this out of here. I got a whole bunch of good 50L6s here. Or, well, good might be generous for 1 or 2 of them here. So I'm pretty sure the number we're targeting on the sheet is the lowest number you want to see. Or in my other tube tester, it's called the reject point. That's what they like to call it. Okay, you can see the heater coming on. Oh man. Okay, we'll go looking for shorts. 2. 7. Nobody else. I put this on short. I see this get brighter. I put this onto this blank spot. Something's being turned off when you do that. Okay, we'll leave it in test where it has to be. Line, bias, we're up around the 3. Ready to test. Okay, man. Show us what you got. 4.2, I would say on there. 4.2. 4,200. 4,200. So the end result here is 5,000, 3,500, 3,000, 5,400, 4,200. That's pretty interesting. We're all coming out significantly different. Be interesting. I put these through other tube testers, or later on run it through this one. So I can use any one of these I want. Why don't we use tube 1? It's exactly 5,000. That's a nice round number. 5,000. The other one is round number is 3,000. It's a round number because I wrote down a round number, for crying out loud. It's one of those circular logical things going on there. Switch off the power. Leave the tube in. No, we want to put in tube number 1. Tube number 1. Number 1 is in. Now we want to go back to reading the instructions here. Adjust the front panel controls for a 50L6 tube. Remove the leads. Repeat above. 2 and 7 ones are right. Return test switch to off. Meter switch to test. Without changing any settings, turn instrument off, which I did. Here, remove. This is what I got to do now. Remove the lead to lug 14 of PT4 and connect it to 13. Here we go. So 14 of PT. So first I have to figure out PT4 and lug 14. PT4, lug 14. This is powered off. this out because I'm going to be turning this over now. PT4. Nice and cool, ever so slightly warm. Good. Which is which? Which guy is PT4? I'm going to flip this right over. Okay, PT4. Did anybody take the time to write it down? There. No, because how can you get these confused? Look at them. I can get them confused. Let me work on that for a second here. PT4. So PT3 is the one that's producing all the voltages for the heaters. PT4 is the other one. So I think we can be pretty sure this is the heater guy. He's just got a million leads coming off him. So this would be PT4. And you want to find pin 13, I think it was, wasn't it? Wasn't it pin 13? Remove the lug from 14 and put it on 13. Remove it from 14. Which one of these is 14? 16. Remember, these were numbered all funny in here too. Funny, haha. So let's use the close-up camera on this. And okay, let's see if we can spot number 14 on here. 16, 10. See, that's 12. Hopefully 13 and 14 are side by side, so we shouldn't really find them there. Let's take a look on this side. Ah, 17. 7. We need more terminals. Maybe I got it wrong. Maybe this is the other transformer. That's 15 under there. It looks like 12 or 2, 7, 17. What gives here? That must be wrong. About which I gotta make a better identification. Unless it's these last two and I just didn't really move the wires enough to see. Oh, there's a 14 there. And that one I thought was 12 is 12. Well, we found 14 on this transformer, but no 13. There's 13. Okay. That's a 13, all right. Okay, so 13 on the top, 14 down there. Well, great. That's not the easiest place to get to. And what do they want me to do with it here? Let me flip to the other view. So it's 13 and 14 down here. And it says, what are you supposed to do about those things? Remove the lead to lug 14 and connect it to 13. Wire's not even long enough to do that. From down here, Take it off 14 and put it on 13. Was this ever done? Could have done it and then just trimmed the wire afterwards. Is that really what the is that really what it says in the book? Without changing any settings, turn the instrument off, remove the lead to plug 14 of PT4 and connect it to 13 of PT4. Okay, now how do we know for sure that this is PT4? I'm not about to make a stupid move on here. How do we absolutely know? So out of PT4 is a capacitor to ground. I don't think there's one on this one. Okay, let's look at the schematic here. So it's either this or this. So this has got 1 to 19 coming out of it. It's got a 19 coming out of it. This one got a 17. Doesn't get to 19. If we find a 19, we found PT3. Find a 19 is PT3. I think I might call that a positive identification. There's a 18, there's a 19 right here. Okay, so no doubt we're on the right one. This yellow wire's got to come off that terminal down there where it's hard to get to. Son of a gun. We have to probably, oh, you know, we can move it over to here. We can move it to here, but it won't reach there either. I can pull it back and get it over to here. Well, if I pull it back through here, I can get it right up to there. One way or another, I'm going to get it there. One way or another. This is the kind of thing I don't like doing because there's no explanation for why this is being done, what the, you know, and if I were to study the schematic and try to sort this out, I might never get there. I never really understand why they want these things done during a calibration process. We're unplugged and turned off, yeah. Done a better job of it than I had hoped. There. Okay, so I have a little wire extension soldered in there. So now it's removed from 14 and attached to 13 as per the instructions. I gotta flip it over now. Okay. Now, the objective here is to watch for a meter movement, similar to a previous test. Let me just get her up. Here we go. So, turn the set on and allow a warm-up period of 30 seconds. Turn the set on. Okay, 30 seconds. And then after 30 seconds, I am supposed to rotate the test switch to test. Be this. If meter deflects from 0, adjust screwdriver potentiometer P3 until no deflection is noted. So the last time I did this test, there was no deflection. I couldn't get a deflection. So that's about 30 seconds now, I guess. Rotate it to test. Let's get a good close look at this. Just stick my camera here like this. Can't get much closer than that. There it is, right there. Okay, I'm now going to flip the switch to test. It's exactly the same as the last time. There's absolutely no movement. So, and I'm not going to fiddle with it any further. These two tests, they don't give me a good feeling. Okay, power off. Oh, let's read what it says. Read what it says. Don't make any assumptions. If adjustment of P3 cannot zero the meter, make it stay zero or whatever, then do that. Replace lead move from 13, so put it back. All that just to put it back. Put it back, okay? Will do. Put it back, power off. Gonna put it back with the power on. Would not be advisable here. Flip this over. Solder spray there when I pulled that off. Little tiny tidbit of solder there. Sprayed. Hey, when I pulled that, I guess I shot solder in a couple of directions. Come on, it's hiding from me. So this guy goes back down under. Get a wire in there. No. Don't move that. Okay. See if I got it. Yep. Just gonna leave it like that. Leave it like that. What I mean is I melted off some of the insulation on that yellow wire, and I was thinking about repairing it. There's no need. So there we are there. There we are there. Incidentally, you can see the power cord come in here and split. And one goes right over to the terminal of this light bulb, which is the dim light bulb system that's built right into this guy. So where are we at now? So we've done that. We did that. Let me flip it. Before I flip it, let me look at what it says next. Replace the lead to 13, to 14. I did that. You know, I did that last thing with the tube not in. I'll bet you that was a mistake. Oh, man, do I have to do that over again? Son of a gun. That could be what went wrong with the last time I did this test. This type of test earlier. That, I didn't have a tube in or something like that. You know, and it could happen right for the same reason. You're flipping the thing over. You take the tube out to flip it over. And the tube's out, you got to think to put it back in. It's that thinking part I have trouble with all the time. Watched a video. I wish I could tell you who it was. It was a researcher, a doctor, a scientist, something like that, and talking about how our minds are structured. And I was blown away by what this guy said. And I wish I can't repeat it here. I'm just not able to describe it. So sorry I even brought it up, because it gets you curious, and then no way to go find out for yourself what I'm talking about. To try to dig this video up, it was just a mind blower, literally. Talking about blowing minds. What did I do with the solder? There's another mind blower. What did I do with it? I thought I set it here. And I put it right here in front of my face, practically. Yes, theory of mind, including consciousness and everything, and it's kind of a model this guy's come up with. You look at his model and think about it, and it can help you adjust your thinking, literally. He's doing this with people who he's working with, I think, criminals, and is using this model because, you know, a lot of criminals, it's just bad thinking that gets them there. They just thought things a little differently. They wouldn't dare hurt somebody else. Some of them, anyway. So anyway, this guy gets criminals to think differently, and by simply studying the model of how your mind works. And it's not a simple thing either. It's not some. Anyway, I think this guy's really onto something. It's a mind blower. And are you watching Sky Scholar videos? Just a warning about Sky Scholar videos. The person who's presenting them, who seems to be, it seems totally legitimate to me, seems to be able to point out what's wrong with everything else that's ever been figured out. So I'm a little hesitant now about this guy. His name is Robitaille, Jean something Robitaille. I mean, that didn't solder. He is challenging almost everything. And you gotta kind of wonder. But, you know, I like the idea of thinking stuff over. I'm not, you know, it's good to return to old ideas and double check them, especially in the light of new knowledge, which, jeepers creepers, every day this world fills up with more new knowledge. It's a great world we live in. People should not be upset. But it seems to be just kind of the mood today. It's happening in my country too. People are angry. Want to be angry at somebody? Just go look at the people who've pooled up vast amounts of money. Go be angry at them. Okay, not to be political here, Jim. I'm just frustrated because I had to do this over. Okay, let's try it again. Flip it over. Put the tube in. Test 50 be off on here. Don't make any adjustments. So it says power on. Everything's looking normal. Now just while it's warming up for 30 seconds, rotate test switch to switch. If meter deflects from 0, adjust screwdriver potentiometer P3. Until no now, if I get a deflection here and I have to zero it out, then that's going to tell me that the earlier thing I did, I probably made the same mistake. It performed the test without the test tube in place. Okay, don't get too far ahead of yourself, because chances are this isn't going to move at all again. Let's see. Let's see what happens here. Will. Okay, we're on full power. Everything's normal. Tube's lit. Ready to go. Will the pointer move? Oh my gosh. Well, that's a good and a bad thing at the same time. So I think I know now why the test didn't work both this last time and the last time. So yeah, I'll do this, but I think I'm gonna have to start right from scratch and come forward on this thing. P, which one was I supposed to adjust? Oh, I don't know. I got bad feelings here. I've lost my mind here. P3. P3 to 0 the meter. And 3 is way up, way up. Oh my gosh, way up in there. Okay, so I'm on my hands and knees getting my tool into the right place here. Ay, 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 ay. Give me the insulated one. Okay, I'm going to get into P3 here. I'm in. Okay, I can stand back up now. Just checking again, make sure it is P3. Okay, we're gonna P3. Come on. Oh, that's P3 all the way one way. It's P3 all the way one way. This is where it was. It was all the way the other way. You know what? This machine has never been calibrated. That's two controls I found turned all the way. The wrong way, in fact, from where they... How much you want to bet if I did the other one again, the first one with the 6C4, if I got that up, maybe I can get this one up then after that. Okay, big lesson learned there. Big lesson learned there. You really shouldn't have expectations of success first time through on anything, of course. It's just a question of how much bloodletting is going to go on. So what I'm going to have to do is I'm going to have to go back with the 6C4, repeat this style of test earlier on, and try to correct this meter. I think the state is somebody didn't do some of these calibrations. Maybe they did some of the easier ones. It didn't bother with the ones I'm doing now. That means I got to put those 2K resistor back in. Oh, okay. I think I know what I'm going to be working on a little later today. But for now, that's it for now. Thanks for watching.